Today we're going to be talking about waves. Let's start off by defining the word wave. A wave is the motion of disturbance. The motion of disturbance. Now we have many types of waves: mechanical waves and electromagnetic waves. Some waves require a medium. A medium is the physical environment through which a wave can travel, or a disturbance can travel. Which a wave can travel. An example of this would be sound waves. Sound waves require a medium. So for example, in space, there's no sound because air is not present there, so there's no medium. Another example would be the ripple in a pond. So since the water acts as the medium for the ripple to take place. So these types of waves are called mechanical waves. So mechanical waves are waves require a medium. The second type of wave is electromagnetic waves, and these waves do not require medium. For example, X-rays, visible light, ultraviolet, gamma rays, microwaves. These are electromagnetic waves and they do not require a medium. Do not require a medium. Okay. Waves are classified as two types of waves. First, we have transverse waves. This is how the transverse waves looks like. These high points are called crests. Low points are called troughs. The region from here to here is a wavelength. This can also symbolize wavelength. Okay, now the crest is the highest point above the equilibrium position. So as you can see, this is the equilibrium position, this is the highest point, so this would be the crest. The trough is the lowest point below equilibrium position, so this is what the trough is. This is also a crest. Now a wavelength is the distance between two adjacent similar points, so it could be from crest to crest, or if we continue the wave, it could also be from trough to trough, from this point to this point. All of them can be classified as wavelength. We also have amplitude, which is from equilibrium position to the highest point or lowest point. So this and this would be amplitude. Okay. The second type of wave we're going to talk about is longitudinal wave. So a longitudinal wave is a wave whose particles vibrate parallel to the direction of the wave. Whose particles. Now, unlike the transverse waves, which the particles vibrate perpendicular to the direction of the wave, these waves vibrate parallel, not perpendicular. Direction. Now these waves differ in the illustration as well. So this is how the longitudinal wave looks like. You can think of it as a spring. Now we have these compressed regions, which is compression. These stretched regions, which are also called rarefactions. Now we have a wavelength as well, which can be from any two adjacent points, so from here to here, or from here to here. Now the compressed regions correspond to areas of high density and high pressure, and while the rarefactions, or the more stretched regions, correspond to areas of low density and low pressure. Now, an example of this would be sound waves. So sound waves, this is how it would look because it's a longitudinal wave. You can think of it almost as a spring. So some regions are stretched, some regions are compressed.